You ever just stare into a campfire? Feel that pull? Well, that beautiful dancing glow, that's not magic. It's a full-on chemical war happening at the atomic level, releasing an insane amount of energy every single second. Okay, let's get into this.
We are going to pull back the curtain on this incredible and frankly terrifying force of nature to find out how fire actually works. So forget everything you thought you knew. This is the real science behind the original and, let's be honest, the best light show on Earth.
All right, so to understand this chemical beast, we got to start with the basic recipe. Think of it like a heist. You need 3 key things to pull off the job.
Now, most of us learn this in school, right? The famous fire triangle. First up, you need heat. That's your spark, the energy that kicks the whole party off. Then you need fuel. You know, the wood, the gas, whatever's on the menu. And finally, you need oxygen, because fire's got to breathe, just like us. You put those 3 together, and boom, you get fire. Sounds simple enough?
Well, not even close. The fire triangle, it's a great start, but it only explains how to light a fire. It doesn't explain how that little flame becomes a raging, self-sustaining inferno. There's a secret ingredient we're missing.
And this is where our whole understanding gets a major upgrade. We're moving past that simple little triangle to something way more powerful, a much more complete model of how fire really works.
See, just having heat, fuel, and oxygen hanging out together doesn't guarantee a fire is going to keep burning. Something else has to kick in. A trigger that turns a tiny spark into a roaring blaze that just feeds itself.
So, let me introduce you to the fire tetrahedron. Yeah, it's the triangle, but with a 4th side. And that 4th side represents the single most important part of a fire that keeps on burning, the uninhibited chemical chain reaction. This, my friends, is the engine of the inferno.
And this is the absolute key. Fire isn't really a thing. It's a process. It's this violent, brutal, ongoing cycle. The heat from the fire cooks the fuel, which releases more flammable gas, which then burns, which creates more heat, and on and on and on it goes.
So what on earth is this chain reaction? Let's zoom way in, right down to the molecular level, and see the beautiful chaos that happens when a fire truly comes alive. We're talking about the atomic domino effect.
Okay, so first, something totally wild has to happen. You see that solid log of wood? Get this, it can't actually burn. Nope, fire can only eat fuel when it's a gas. So the initial heat starts this process called pyrolysis. It's basically cooking the wood without any oxygen, breaking it down and releasing these big clouds of flammable gas. That smoke you see, that's just unburnt fuel waiting for its moment.
Now, as the heat is ripping those fuel molecules apart, it creates these little monsters called free radicals. These things are hyper-reactive, totally unstable little pieces of molecules, and they are desperate to cause trouble. They are the renegades, the first dominoes, and they will react with absolutely anything, but they especially love to react with oxygen. And when they do, bam, they let loose a ton of energy, and in the process, create even more free radicals. So each reaction triggers a bunch more, creating this explosive, self-sustaining cascade. It is literally an atomic chain reaction that grows exponentially, like a microscopic fireworks show that just keeps setting itself off over and over again.
Now look at this. This isn't just some boring graph. This is like an EKG for the fire. You're looking at the monster's heartbeat. You can see the initial spark, then a little bit of burning, and then look at that spike. That massive jump, that is the exact moment the chemical chain reaction goes into overdrive. The dominoes are falling faster and faster, releasing this incredible wave of energy. That's not just a fire anymore. That is an inferno being born right before our eyes. Okay, so all of this violent chemistry is releasing a ton of heat. We get that. But what about the light? Why do we see that mesmerizing, dancing flame? Well, it's because fire is basically atoms throwing a rave. The heat gets the atoms so incredibly energized and excited that they literally jump to a higher energy level. But they can't stay there forever, so when they fall back down, they have to get rid of that extra energy. And how do they do it? They spit it out as tiny little packets of light called photons. We're talking billions of them every second. That's the glow. That's the light show.
And the color of that light actually tells you a story. If a fire isn't getting enough oxygen, it can't burn up all its fuel. We call that incomplete combustion. The leftovers are these tiny bits of carbon, soot, that get super hot and glow with that classic yellow and orange color. But if you give a fire all the oxygen it could ever want, you get complete combustion. The fuel burns super efficiently, and the flame turns this intense, clean blue. So now that we understand the fire's four-part secret identity, the tetrahedron, we finally have the blueprint. We know how to defeat it.
And the strategy's actually brilliantly simple. To kill the fire, you just have to break the tetrahedron. You don't have to fight the whole thing at once. You just have to take away any one of its four essential sides, and the whole structure just collapses.
And that gives us our four main weapons. You can cool the heat. That's what water does. It just sucks up the energy. You can starve it of oxygen, basically smothering it. You can remove the fuel source so it has nothing left to eat. Or, and this is the really cool one, you can attack that fourth side directly and break the chain reaction itself, using special chemicals to get in there and stop those crazy free radicals in their tracks. So, in the end, fire isn't really a thing. It's not alive. It's just physics and chemistry gone absolutely wild. So the next time you light a match or see a candle flicker, just take a second. Appreciate what you're seeing. You're not just making a little flame. You're kicking off an atomic domino rally, unleashing a tiny, controlled version of the very same chemical process that powers the stars.